Thank you so much for coming. I know you got a lot of choices. And so we have clearly the last standing remaining diehard JMS people in the building. This is pretty cool. So I'm David Blevins, and I work in a company, Tomitribe, and we're part of the whole Jakarta EE working group. We're one of the co-founders of MicroProfile, and I've been really obsessed with EE for a really long time. So there's a lot of fun background to this talk. And so, the overall arc that we're going to try and cover is what happened to JMS 2.1. So many of you may not have known that we were actually working on another version of JMS at the JCP. So you're currently out there is JMS 2.0, and we were actually working on a 2.1, and it died. Where we're at now that everything's transitioned to the Eclipse Foundation as Jakarta EE. So before I mention that, who's heard of Jakarta EE? Okay, so for the hands that did not go up, basically what happened is Oracle decided to open source JavaEE and pull all the TCKs out from proprietary source and give them to an open source foundation so that way they could be developed by all the industry partners together equally. And so there were some troubles with EE, and it kind of got killed and then revived. And as part of the process of reviving it, it got open sourced to the Eclipse Foundation. Unfortunately, we were not able to keep the trademark JavaEE, so it got renamed to Jakarta EE, and there is a whole bunch of stuff that happens there. Then we're going to talk about JMS, or now technically can't be called JMS, Java Message Service, because trademark. It's going to be called Jakarta Messaging. And what we're going to do in the 3x stream, which is the next major revision, taking up where JMS 2.0 left off. And then, of course, how to get involved. So now one of the advantages of it being an open source project is that the barrier to entry is basically zero. And if you'd like to go ahead and participate in the project, there's nothing stopping you other than yourself. Okay, so here's a recap of the timeline of JMS. So JMS 2.0 was delivered in the 2013 timeframe in JavaEE 7. I'm going to give, if I think we're going to have time, a brief overview of what we did in 2.0. And then immediately after that, we bootstrapped JMS 2.1. We launched off the JSR. We're going to work on some really cool things. And so that was September of 2013. We basically started working on that at Java 1 during there at the conference in September 2013. So we proposed that. And then, it got removed and withdrawn in 2016. So basically what had happened is between 2013 and 2016, all the resources were pulled off of all of JavaEE, all the Oracle resources. We launched off the MicroProfile in June 2016. And then it was announced, we're going to do this JavaEE 8 thing again. We're going to pick it back up. We're going to keep it going. And as part of the plan to deliver JavaEE 8, they decided to cut scope and eliminate JMS 2.1 from the JavaEE 8 perspective. And so some of the things that we were working on in JMS 2.1 was a completely annotation-based approach to consuming messages, which I'll show you in some great detail. And it was very, very, very frustrating for me because there were some blockers to enabling us to start working on JMS 2.1. So JMS actually connects through to JavaEE through this thing called the connector architecture. And the connector architecture is this old thing you've never really thought of. It's what MDBs use. And there has been a blocker in the connector architecture where you couldn't actually use annotations on the bean because the connector couldn't see the bean class in any way. It only saw like these string configurations. And so therefore, doing something like JaxRS, but for JMS, was impossible without a change to the connector architecture. And I pushed and I pushed and I pushed on that. You'll find presentations from me in like 2013 and 14 where I'm giving talks like infinite extensibility meets infinite reuse, and I'm talking about how we can change the connector architecture so we can, explode many options to do connections from SSH to HTTP to more advanced JMS usage. There was a feature that we needed that I managed to get into the connector architecture just barely before we closed the lid on EE7. In fact, I implemented it in Glassfish, even though that's technically a competitor to mine. I was like, whatever it takes to get this feature in to the EE spec so we can start doing the really fun stuff of annotation-based message-driven beans. And so that barely got into EE7. And so like by the time 2013 came along, I'd been talking about this for quite a while. And when 16 happened and that thing was withdrawn, I had already been working on this for like 4 years, and it was really disappointing to see that thing closed. So everything delivered eventually. So EE8 was delivered in August 2017. That was the last JavaEE implementation that will ever exist as JavaEE. Then in September of this year, after all the processes of donating all of JavaEE plus all the TCKs and the APIs and everything to the Eclipse Foundation, we were able to finally deliver Jakarta EE9, which is identical to JavaEE9. And that was done on purpose, so that way, basically, if you had a product that ran on JavaEE9, you could run it on Jakarta EE9 because they're the same. There's no change. However, all the TCKs are now open, which they were not before, and that's a really huge thing. Who knows what a TCK is? Okay, so a TCK is this really big test suite of like 40,000 plus tests that take a week to run, and IBM, Red Hat, ourselves, Oracle, Pyaro, we all have to pass this TCK in order to ship our thing and call it JavaEE or call it Jakarta EE. And so it's the compliance test suite we have to comply to, so that way we can give you something that doesn't have portability issues to the best of our ability, right? If there are portability issues, it usually means that there's a TCK gap or a feature gap in the spec. So those being open source is a really big deal. That's a whole nother talk in and of itself. But it's basically, it's a major shift in our industry, so it's really positive stuff. So where does all the new fun Jakarta EE stuff come in? All right, so Jakarta EE9 is being worked on and delivered as we speak. And what the plan is more bad news. Not only are we not going to get usage of the Java trademark in the names, we're not going to get usage of the Java trademark in the package. Sorry. That's an Oracle trademark decision, so we all just have to suck it up. And what that means is literally we're going to break compatibility on 20 years of code. And that's a terrible thing. However, once we're done with the change, everything will be open source and free from Oracle legal. So, there is some positive things there. And so we're going to deliver basically what is effectively JMS 2.0, but with the rename done and nothing else in Jakarta EE9, and that includes Jakarta Messaging. So the very first version of Jakarta EE, of Jakarta Messaging 3.0, will actually just be a straight rename from JavaX to Jakarta. So that way you can just do a find and replace in your app, get that thing to deploy, get across that bar, and the whole industry can start working on better tooling for all that. And then after that's done, we will start actually working on implementing some of the ideas that have been in the pipeline for quite a long time. So if you see back here, that's a lot of patience. We went from 2013 to 2019 to basically deliver the same thing. right? So it's kind of interesting. A lot has happened in the industry in the last 6 years. Like all these other messaging paradigms have really gotten popular because JMS was not moving at all, right? And so, people have in their head what it is and what it's not. Well, JMS is not really good for this. You should use this, that, and the other thing instead. The fact of the matter is all specifications can evolve if they're allowed to. So this one was actually blocked from evolving. And so that blockage is now getting cleared. And so what this is going to look like going forward is after the 3.0 is delivered, and this should be around the September time this year, we're going to keep delivering on that branch new functionality. And so, who knows? Hopefully, we're not intending to deliver, 3-year gaps like we used to do. I mean, so one of the really big things we're hoping to get is that we can deliver all this stuff much faster. And so that is, in that range is when you're going to start seeing the new things that I'm going to be talking about in this presentation. Okay, just keep my timer here. All right, so who is using JMS 2.0 right now? If you are, I can skip this. Okay, not too many people. Who has used JMS at all? All right, well then I'll give this chunk of the presentation. So here's the 2-minute perspective of what JMS is. So in JMS 1.1, which sounds like what many of you are using, you had a lot of boilerplate. And so all those things were required just to send a basic text message, right? And so there was a lot of ceremony. You had to get a session, then from a session you had to create a producer, then you had to go ahead and create a text message with the payload, and then you had to go to the producer and send that. So you're like interacting with like 4 different things to glue them all together to send one stinking text message, right? So it's a lot of boilerplate. So that got really condensed in JMS 2.0. Basically what happens is there's now closable implementations of a lot of these things, so you don't have to deal with closing them in the try-catch. And we cut out the number of things that you have to interact with to basically like 3, including the message itself. And so you can get a lot of the things injected. And that's a pretty great improvement. Also, there is basically a builder API for everything that existed in JMS 1.1. In JMS 2.0, we added a lot of building types of things, so you can use fluent interface styles. So you don't have to be declaring variables and referencing variables all the time. You can just chain the calls together. And so there's the 1.1 equivalent, and there's the bottom 2.0. And that's for messages that are, not text messages. When they are a text message, it's even simpler. There was the 1.1 version of sending a text message, and there is the 2.0 version of sending the text message, and it's way smaller. So good improvements, very good improvements. But what a lot of us were hoping for were some bigger things. So if I were to describe what we did in JMS 2.0 and what we were intending to do in JMS 2.1, is I would say the big difference was the improvements in JMS 2.0 were all programmatic, meaning code you write that executes at runtime that can change itself based upon what's happening in the environment at runtime. You can have if statements, and it can alter itself, send to a different topic, send to a different queue, build up the message differently. And in 2.1, we were intending to do declarative-based things, basically meaning annotations. You declare on your code via annotations what you want to consume, what you want to send, and once it's compiled, that logic is now static. So one side's dynamic and one side's static, right? And so we were intending to basically make it far easier for you just to declare what you want to have happen, and then the runtime figures it out on your behalf. And so we're going to talk about that, and then we're going to talk about this roadmap of ideas that have occurred in the several years since JMS 2.1 was decommissioned. All right? So the problem with MDBs. So MDBs is how you declaratively consume messages now. Who happens to be using any message-driven beans? All right, like 1% of the 5% of the room. And so, yeah, I don't blame you. So honestly, so the EJB spec was my first spec that I worked on. And our priorities were pretty much this. JPA, right? Getting rid of CMP, that was like 80% of the priority. And then 19% of the priority was improving the session bean API a little bit with nice annotations. And 1% of the priority was improving MDBs. And so basically what we did is we just sort of copied the XML into annotation format and said, does that look good enough to everybody? Yep, that looks good enough. Boom, done. That was like a week we spent out of the several months that we worked on EJB 3.0. So this is pretty bad. You know, at the top, you have these activation config properties. And it's really sort of terrible because there are key value pairs still, and the point of an annotation is strongly typed key value pairs. But you have a key that says, you know, what is the name and what is the value in string still, so we completely missed the opportunity of what annotations were supposed to be for, right? So if you want to know what properties to put in, you can't use tab completion because you got a library. You got to go look up on a web page and you're in HTML land sifting through, copying and pasting strings in that you could type wrong. Oops. So also, not strongly typed in the data value, right? So here's a reference to a class. Okay, that could actually be a class reference, but since we have string values, it's not. Right, and so it could actually even tell you that class has to be a subclass of destination, you know, or something of the sort, but it's not. Also, this is one of the things that's very subtle, but if you think of servlets, servlets has one big service method or one big do-get or whatever, and that's all gets that service responds to go to that. And in JaxRS, you have many, many gets on a method that are all strongly typed. So we learned that when you have one big method that consumes HTTP message and you got to start from there, the amount of boilerplate you have to write is enormously high. And JMS and MDBs are the same way. You've got all those properties on the top, and you can only have one way to consume messages in that method right there. And you have to implement that method listener interface, which is like the servlet, you know, class or HTTP servlet, and it pins you to that method signature. So all of this is like so 2004, right? And what we really need to be at is to learn from JaxRS. Have annotations that the runtime provides that you can use to describe to the runtime how you want messages delivered to you, and you can define any number of method signatures that you like. So who's using JaxRS? Okay, I expected way more hands. Okay, well, who's seen JaxRS? All right, there we go, at least more hands. Some of you might be using Play or something like that, I'm guessing. Okay, so what we want is we want no static interfaces that we have to implement that pin us to one way of consuming messages. We want a way to define the things we want out of the method signatures. We want annotations to help us do it. And everywhere there's configuration to describe what we're telling the runtime, give us these messages in a certain way, we want strongly typed annotations for that. Okay, so here is where we're going, right? And so at the top, we have max sessions and max sessions per message, you know, messages per sessions. Those would be like vendor-specific configuration that you would normally have put in those strings at the top. And in the bottom, we not only have just one, but two different ways to consume messages from this thing, just like JaxRS. And so this is a mock-up of what basically launched the JMS 2.1 effort. And this is exactly what we're working on. So this is a rolled up version. What we ended up with is a little short of this, but that's the rough idea of the mission statement that we were trying to get to with JMS 2.1. So I'll show you where we left off and all the things that have occurred in the time since. So the JMS Jakarta Messaging expert group, as they used to be called, now it's just a specification project. That is still very nascent state, in very nascent state. So the big work of the last 2 years has been trying to get all the proprietary stuff open sourced and released. And now we're doing the namespace change and release, so that's where the focus is. So what I'm showing to you right now are harebrained ideas that have occurred into my brain since the time that we worked on JMS 2.1. And so they're not set in stone, there isn't any implementations of them, and if we want to do things differently, we can, and so you can consider this to be one of the very first official JMS expert group meetings. Welcome, meeting is in progress, roll call, okay. Everyone here is in attendance. All right, so I'm gonna show you some cool little stuff that we had. Yeah, awesome. All right. So this is the proposed JMS 2.1. Oh, that's really tiny. Let me see if I can. Those projectors are a little bit hazy. Is that better for you guys? Yeah. Okay. Yeah, good call. Moving up. There's a lot of code in this presentation. Okay, so we have several new annotations. Well, basically all the annotations that are JMS related are new because JMS 2.0 does not have any annotations. And so first thing to pay attention to is we have this new annotation called QListener that defines I'm going to receive messages from a queue called project.build. And so throughout this entire presentation, I'm going to use the same classes and continuously improve them. All right? So we're going to say that we have a fictitious scenario where we are writing our own build system, and there's a queue that has all the builds on it, and we're going to take a message off the queue, and then we're going to build that thing, and then we're going to send a notification that said whether or not the build succeeded or the build failed. So we got a queue, and then the second one is a topic. We're just broadcasting to anybody who cares. Did it pass? Did it fail? That's our that's our pattern. So here we have QListener, and also it says this is a new annotation that basically says, please tell me where I'm supposed to send the response, right? So in JMS, you can have, there's a bunch of standard headers. And in fact, JMS has this concept that's headers and properties, and they're both sort of like HTTP. A header would be like a standard HTTP header, and a property would be like if you put the X dash in front of it, that's non-standard header, right? And so the standard stuff is called a header in JMS, and the non-standard stuff is simply called a property, but they're both basically affixed at the top of the JMS message and delivered to you. So when we're receiving this message from the build queue, in that message there will be a header that says where I should send the notification that it's done. All right? So I have that injected as a topic. Topic is a standard JMS class, of course. And as you notice, I already have it renamed Jakarta JMS. So realism, even though this is a mock-up. Okay, and then so we're taking an object message, and of course we're casting it to project. So we have a serialized object called project, and then I build the project, and this is just a mock-up method, right? We don't need to understand. That can do whatever it needs to do. And then we send the value back. If we had an exception thrown, we're going to send a fail to the build notifications topic. And if it worked, we're going to send a success to the build notifications topic. And now we have this little class, which is the way you would consume a message from a topic via annotation. You simply say, topic listener. This one listens on the topic called build notifications. There could be many of these listeners out there. You could have a bunch of methods annotated with this particular topic, and it would all work fine. And here are the message properties that I mentioned. Is basically in the thing when we send the message, we could put information about what we built, right? And so these would be like our, in HTTP speak, our X dash headers. All right, so we have a bunch of things that we have. These are all application invented properties. And then we go ahead and we just log passed, fail. And of course, we can have another method because that's the advantage. We don't have to have just one per bean. We can have several per bean, just like in JaX-RS. All right? So that's great. It's a good start, but still not perfect. All right? This is still an MDB. This is still an EJB. So let's have a huge round of hands where all of them are going to go up. Who wants to be writing a lot more EJBs? No one? Come on, one hand? Not one hand? All right. And for the video, there's now like 100 people in the room, and no one raised their hand. Okay, so that annotation is a fancy MDB annotation. That is message-driven. That is from the EJB API. And JMS message-driven bean was the proposed interface that you would have to implement in order to have this style. This is that little interface. Has no methods in it. And that was the thing that we added to connector 1.6 that allowed if you had a connector that had a connector interface and there was no methods in it, then the container was allowed to pass the bean to the connector and said, here you go. I know I'm not going to break you by giving this because you're a new connector and you have a method interface with no methods. And so this was the way we were going to tie things together in the work that we had in progress in JMS 2.1. It just so happens to be not what we want to be doing anymore. And so that brings us to the real first post-JMS 2.1 improvement idea, which is, hey, let's CDI all this stuff, right? Let's use CDI beans for all these things. So who has heard of CDI? Okay, that was a few hands. So CDI is basically a component model that was added to EE in the JavaEE 6 timeframe, and it was created by Red Hat based upon this programming, this project called Seam, and it basically was like the spring for JavaEE. It allowed you to do dependency injection, really, really fancy. But I would really be more honest to say it was more like Spring plus Juice, because it has qualifiers and things like that that are concepts from Juice. So CDI basically took all the best concepts of dependency injection that were happening at the time and came out with a new specification that got added to EE, and it's a whole nother talk all in itself, but it's awesome. And since we have CDI, we don't really need EJB anymore. So the way we would do that is this. So instead of having at the top of our notifications listener message-driven, right? Now we simply have application scope, which is a CDI annotation. So let's just check out these imports here so you can see that. We don't need that one. And yeah, so application scope is a CDI bean annotation. And that basically says, that's like equivalent of Spring Singleton, right? So that means they're going to have one of these instances that's going to be consuming all the notifications that come off of this topic for that JVM. And of course, there are other ways to do things in CDI. You can have also request scoped. And that is basically meaning that we have one instance per request. Every time a message is taken from the topic, we create a new bean, we hand the thing in, and then it runs it, and then we discard the bean, and so it's inherently thread safe, right? And so those two are two scopes that EJB CDI has, and so why not allow CDI beans to consume messages from the topics and queues? All right, now we've made a pretty big improvement. Even though we've saw just a small bit, we've completely ditched EJB at this point, so cool. However, it's still not that great, all right? In JaxRS, you're not restricted to getting injected headers and path params of just type string, int, long, and the primitives. In JMS 2.1, we were only aiming at the primitives. And so, that is really, really restrictive, and that makes code look like this, where every time you want to pass a custom header, so to speak, you get it as a string or an int or a long, and therefore you have code that can easily not work if a string you weren't expecting gets given to you, or you have a typo, and basically every time that you want to get something into a strongly typed object, you're parsing. So we got a little bit of an advantage, but we would still have a lot of boilerplate that we would normally have in the servlet world, right? If you were still, like imagine JaxRS where you're still parsing all the strings. Be like, no fun. What's the point? It's like, you got me real close, but then you just dumped me off and left me there, and now I got to still do a lot of the garbage that I would have to do. So the first thing that we would want to do is add JAX-RS compatible property conversions. So any object that can be converted by JAX-RS could also be converted by this new Jakarta Messaging API. Right, so that's the... Okay, so instead of what we had before, which is that, right? String, 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 string. We now do this. Here, that is an enum, right? And it's got a value, pass, and fail. And we can pass that enum. I mean, in the actual JMS message, it's a string, but it would be parsed as an enum when this method is by the container, before this method is called, just like this would happen in JaxRS. And instead of having a string test this value to see if it is equal to fail, we now can use a switch case, which is compile checked. No one can give us a value that doesn't exist. And when we get something, we know it's one of the things that we're already coded to handle. So now we have compile time checking of our code versus those strings that we had before, which can easily get mistyped. F-I-A-L happens on occasion. Compile time checking is really, 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 really necessary. Okay, so we have that going on, and then before we had a long in there for the date, now we can have an actual date object. Here we have a build ID, and build ID is a class that simply has a constructor that takes type string. Super cool, very JaxRS-like, and we're all good. Okay, so that's a real big improvement. There's the thing. So that's pretty nice. We have URL, we have basically real data types for everything we're expecting. And that makes our code, of course, obviously much nicer. But as you can tell by the pattern that's emerging, that is still not perfect. So we had those standard headers in there. So a header is a standard way to refer to specific data types. There are only like a dozen of them. And this would have been the way that you would have had to have referred to one of those standard headers in the proposed JMS 2.1 API. It's flexible. Those values are enums, and header message is a class that takes one of those enums. So there's a fixed set, so you can't type anything wrong. It is compile time checked, but that's really long. I mean, like, I'm not really thrilled about typing that in all the time and seeing all that crap on top of the code. I'm really, really picky, as you'll probably see more and more and more throughout this presentation. I would get really frustrated having that at the top of my methods. I don't like it when the annotations dominate the code and I can't see the code anymore. So there was this concept that we worked on in the early days of CDI. It's called stereotypes. And the fastest way for you to understand what a stereotype is, let's put it this way. In Java, you got a method, it's got a bunch of annotations on it, you got a method below it, and it's pretty much the same annotations on it. In HTML, would you do that? Here's an element and all the visual, all the inlined width, height, and all that kind of garbage, and then here's the same element, and now we got all the width, height, and all that stuff again. You wouldn't do that, because we have CSS. We have a way to abstract that stuff out, give it a name, point at the name here. That is stereotypes. Basically, you can say, here's an annotation, has a bunch of annotations on it. That's my CSS class. When I use that annotation on this method, imply all those other annotations. I'm not going to copy and paste that stuff all over the place. So if we take this concept of stereotypes, we apply them to this problem, and we say that inside the messaging 3.0 API, or 3X API, because it all happened during the 3X stream, we're going to provide out-of-the-box shorthand ways of referring to these things. We end up with something that looks a little bit like that instead. Significantly better, right? So now if I want to refer to the standard reply to header, I just say @reply_to. And if we look at the definition of it, it is a CDI stereotype. So let's look at these imports here. So here's the standard annotation called stereotype, and what that means is that when the container sees that on an annotation, look at the annotations that are on it and follow. And it basically unravels it. And stereotypes are just like CSS. You can have a CSS class that points to another CSS class, that points to another CSS class. It's a tree. It unrolls the whole thing and implies that all. So this one is where we have now that longer version, right? And you could still put that longer version in the code, it would still work, but you don't have to. So this would be an idea of one of the things that we could do. And actually, this is a feature that I've been wanting into EE or Java, really, for a very long time. No one has leveraged it outside the CDI spec, this concept of stereotypes. I've done other presentations on it you can look up called meta-types or meta-annotations, where I explain this stuff in detail. And think of your JaxRS class and that pile of annotations you have on the top. Imagine if you could just get rid of that. That would be so nice. Okay, so what we would have is standardly, and you won't be able to see that too well, but there would be a bunch of stereotypes for various JMS standard headers that you could put them on your parameters and have them in there. So again, that's cool, but still not great, because what if we ourselves want to define our own stereotypes to refer to our own headers so that our developers are not copying and pasting the header names all over their code, right? And so this whole thing really needs to be improved. And so if we had that ability for the annotations that we can make of our own creation, then we could make that code look a little bit more like that. So build ID param is not, here, let me make that a little bigger for you. Build ID param is not a standard annotation that's in the Jakarta package, or in your mind is the JavaX package. That's an annotation that you've created that if you look at it, comes in the org example properties package, right? That's your code. And you would put the standard add stereotype on it, telling the container this is a stereotype annotation, and please imply message property with the specific value build ID on it. And I'm showing just one, but you could have several different types of annotations on this. Probably not the message property, but other annotations, right? So stereotypes can have many, many different annotations on them. And so in your own project, you would have a little package where you might put your stereotype annotations, and then you would give them to your development teams, and they would just use them, and if they type, there's no way that they can get that wrong. Their code will not compile if they're referring to a property that doesn't have any meaning inside your architecture, right? And so you've taken your architectural critical property names that you're passing along all your messages, and you've made them strongly typed. And so that's a very, very big improvement. All right, so what's the big flaw now? Well, if we remember our build and notify thing, the thing that listened on the queue, it was taking object message, and it was casting the response from object message to project. Two things are wrong with that. One, boilerplate casting. The bigger one, serialization. Object message uses serialization to take that thing, put it down into bytes using Java serialization, stream those bytes across, and it uses Java serialization to deserialize those bytes. And if the class definition has changed, that deserialization will fail. In JaxRS, you take an object and you bring it down to a JSON message, and as long as whatever on the other side can be read from that JSON message, you're good. So why do we not do the same thing in Jakarta Messaging? Why not allow for some JSONB or some JAX-B integration so that marshaling can happen behind the scenes automagically, just like we're doing now, right? When we write REST methods, we're consuming things that are basically getting passed in application JSON. So the improvement what we need to do is add JSONB and JAX-B integration into the messaging API, JMS, the artist formerly known as JMS. And if we did that, we would get this. Now ignore the fact that I'm not using the stereotypes. See how ugly it is again, just to get reminded? But in our method, we're now taking QListener, and we're taking something of type project, okay? And then it's already been marshaled for us. We're implying the type just like you can in JaxRS. In this world, what we would need to do is add another JMS standard header that is now a MIME type, because that one shockingly does not exist in JMS. Because in JMS, you've always implied the MIME type because there's a fixed type of messages that you can have. Byte message, object message, text message, and so on and so forth. So there would have to be a new style of a new header that would be MIME type, and it would be applicable only to text message. And so if you created anything like this, it would implicitly assume that what you're receiving is a text message, check for the MIME type header, go, this is JSON, so then I'm going to use JSONB to marshal that from JSON into that object. If the MIME type said it was XML, it would use JAX-B and marshal that into the object. Either way, if there was a way to take text to object, any kind of marshaling thing that we have now or in the future, like YAML B, eventually, someday, all things are going to get YAMLed eventually. It's just a matter of time. It would happen. It would work. And so we're implying the target type that we want, and then now we can cut that boilerplate code out. And we're super, super close to Nirvana. But Still not perfect, right? Because although we have the JSONB stuff, in our build notify, we're using this JMS 2.0 way to send messages. And this one may seem the hardest to get rid of, considering that's the newest API. But who's heard of micro-profile REST client? I'm not going to expect any hands on this one. Well, okay, the two people in Tomitribe in the back, you're cheating. Okay, and Tanya, of course, Eclipse Foundation. So basically, the people who are developing the specifications know about it perfectly. Okay, so there's this cool concept which is going to look really familiar, and I won't give out the secret, and we'll see if you can figure out how familiar this looks. But there's a cool concept in JaxRS that was developed in microprofile called the REST client. And I've got a couple of slides for that. So here's a 2-minute overview. This is a digression of REST client in microprofile. So let's say we have this JaxRS class that's got that annotation on it. It says, find me a movie, right? And it's a movie resource, and it responds to path, and there's an application scoped, and it's a get, and it's got a path parameter. And obviously, movie is going to get marshaled to application JSON, real standard stuff, right? We might issue out to our developer community an OpenAPI document, and they will write their own client, and then we hope that they write it correctly, and then when we change the API, we hope they update their client. Hamster wheel keeps going around. But the REST client in microprofile says, well, if you've got those annotations, put them on an interface that has the same annotations. It says path, movie, but there's no implementation there. This is just an interface that defines what your contract looked like. This is basically strongly typed OpenAPI. Okay, so we've got this now interface that has the same annotations on it, and then there is a client builder where we say REST client builder, new builder, and we say build, and we pass in the interface, and then we get something that automatically implements that interface. And when we call methods on it, it's actually creating an HTTP message under the covers, sending that to the server. The server then invokes it using JaxRS on that side, sends a response back. Then we take the response, and we go ahead and marshal that into a movie object and send it back. And so now we have a strongly typed interface. And if every time we have a server-side component, we have an interface for it, we can refer to them all using strongly typed code on the client side. Now, who says this looks a little bit familiar? Yeah. Who wants to guess why this looks familiar? Well, it's basically EJB. That's a remote interface. Right? Anyway, everybody becomes their father someday. It's good to have strongly typed clients. And so this is a really cool thing you can do in the microprofile client, but it's basically saying if you have a server-side definition of a method contract, why not have an interface that has the same contract and then let people invoke the interface and let the smart guts work it all out. So this is a really huge improvement. And so it all works because it's using the same annotations that JaxRS uses on this little interface. And so the annotations describe perfectly on the server side how to consume the message. So why can't those annotations be used on the client side to how to build the message? Makes perfect sense. It's all solved. We already had the problem we already had the solution in our hand. It's like we geniusly invented JaxRS and said we have perfect annotations to describe how to consume this message. And it took like 8 years for us to figure out, those could be used to build a message. And so there you go. Microprofile REST client in a nutshell. So if we did that same thing, all right, so our notifications client is going to look very similar, right? Here is our notification listener in annotation form. We've basically gutted all the code, left the annotations, And then now this is the description of the kind of messages that that thing wants to consume. All right? So we've taken the advantages that JaxRS has, and not just on the server side, we say those can be used to describe how to build messages. When someone goes ahead and has a reference to this client interface, and they call process notifications, and they pass in that data, we know, we being the container, know to send it to that specific topic and put these values into the message as properties with these names, and we know how to build the message. We can send it over. And so what this would look like to use is now we have this. This is a fictitious interface that doesn't exist yet, but it's basically your builder. It says message client, new builder. Maybe we pass in the connection factory we want to use. Maybe that's something we automatically figure out. Who knows? This is all, hand waving at this point. But then we say, just like in the REST client API, build me a client that implements this interface, and then we get back this automagical notifications client. And so when we're done doing build, we simply call the method process notifications, right? And then we've taken this huge code and boiled it down to that. That is way cooler than what we're doing in JMS 2.0 right now. And it's all super strongly typed. You're not building any of these messages and passing in strings and doing marshaling and creating this object type and all that garbage. We got like 2 lines of code deleted out of the boilerplate in JMS 2.0, and we were patting ourselves in the back. We thought we were super cool. That is way cooler. Only possible if there's an annotation API. All right. Okay, so that is the last crazy harebrained idea that I've come up with for this presentation, but if you want to see them all together, here was what we had previously. This is the same code logically, and it fits on 1, 2, 3 screens. And here's what that looks like now, entirely on one slide. So that is incredibly awesome. And if that could be our future, that would be super amazing. It'll probably take us several revisions to get there. I was thinking about this a lot. I had originally done this presentation with 3.0 being the idea for the first major version of JMS, or Jakarta Messaging, after the package rename. But we decided, of course, logically to change all the version numbers in the package rename. So the very first 3.0 API is going to be just the package rename. And I was wondering, well, do we make the next one be messaging 4.0 to tell the world it's a lot of stuff? And then I was thinking to myself, you know what's going to happen if we do that? We're gonna try and fit everything in there, and then 4.0 won't happen for like 3 years, and we'll go right back into the same trap that we are in. So let's try and find a way to do 3.1 with a couple of these features, and 3.2 with a couple of these features, and 3.3 with a couple of these features, and get them into your hands sooner. So that's more likely than what's going to happen. If you want to get involved, now this is the really critical thing. You got to take a picture of that slide, and you got to subscribe to that mailing list right there. And ideally, the subscribers in the mailing list go up by the quantity of people that are in this room and everybody who views this on YouTube in the future, looking right at you. And so, really this is an open source project now. And I think it's super, super important for people to understand that you don't have to just sit there and wait for people like myself to imagine the cool things that might make your life easy. You are incredibly welcome to come and propose ideas. Even if you don't have the best idea, you're incredibly even more welcome to propose things that make your life hard. In fact, that's better. We go through this process when we propose solutions where we solve the problem in the forward direction, and then we ask everyone to understand it backwards. So we go, I have this problem, and it's really detailed and has all these things, and you think about it for a very long time, and you think about the trade-offs, and you boil it down to, I found the solution. Then you take the solution, and what do you start with when you're telling people? Here's the solution, and it works like this, and then no one knows what the problem is, and you spend weeks trying to figure out what it is that you're trying to solve. So it's funny, we do this as humans. We like, oh, we've condensed the problem down to this. We throw all that away and go, here's our beautiful result. And no one knows how you got there. So in fact, a really, really, really awesome thing is for you to come to the specification projects and say, here's what's been making my life a pain in the butt the last several years. I got strings. We're typing them wrong all the time. This boilerplate is, yeah, still a little smaller, but really is still no fun. Anything that you don't like that makes your life impossible, present that to the specification committees, groups, projects. And if you hang around in the conversation when people are talking about solutions, maybe you feel brave enough to weigh in on the solutions. Go, that doesn't really move the needle for me. You're using this stuff like daily and all the time, right? You're the one who has to deal with the trade-offs of these various different things. And so if you feel like something is a little annoying, you should say so. Because probably if it's annoying for you, it's annoying at scale, right? Let's imagine if it takes you an hour to deal with something because it tricked you or you thought it was just a little bit, take an hour times the 8 million Java developers out there, and that's a huge amount of time wasted. So, if you got to imagine all the time that there are a bunch of people in your same shoes who probably have the same thing. You're not the only one. And if someone super clever on your team wrote a wrapper to make it easier, that's the very first code smell that that idea should probably be discussed in the specification project. The second someone goes, I'm going to write a utility API, there's your smell. That is something that should probably be discussed because if everybody could potentially use this utility API, that should be on the specification project. And that's it. We have lunch break, so there's plenty of time. Do you have any questions or anything that you'd like to ask?
Maybe more of a comment, but if you've thought about it, I'd like to hear how.
Sure.
I can see an issue with this similar to what I have in JaX-RS today, where those implicit type conversions, right, when you're binding headers or properties or whatever in, and the value coming in doesn't convert.
Yep.
And I have no real hook to say, how do I need to handle that error? Like the RS spec says, okay, that's going to be a 404 in some weird cases where I believe it should be a 400, right?
Right.
So have you thought about how you might handle that? And so it's different in an asynchronous.
Yeah, that's great. I'm going to repeat for the video. So basically what you were saying was, in JaxRS, if someone passes me a header and that header doesn't convert to the strongly typed object, you get back a 400 or something along the lines. And, in an async world, there's nobody on the other side waiting for a response who then can tell somebody else that something went wrong and how would we deal with that? Does the message get dropped? Does it sit there in the queue forever? That's an awesome question. We probably need to invent another way to handle undeliverable messages because there isn't a consumer for them, right? If you have all these annotation APIs and something doesn't convert because it's bad or just something doesn't match, we can't let things sit there in the queue forever. We're probably going to have to at some point deal with it. So that's a really great observation. We would definitely need some way for there to be a catch-all, give me everything that couldn't be delivered, including the failures. That's a really, really good shout out. What was your name, by the way? Brant Bayman, so everybody on the internet, he's the one who made so your life isn't impossible. Okay, thank you for that. I appreciate that. Any other questions? Okay, who thinks this is probably boring and terrible and they don't see any value in it? Of course, no one's going to raise their hand. Who thinks this is a really awesome improvement from where we left off? All right, everybody's hands work. Fantastic, so thank you so much. I really hope you enjoyed. If you want all the stuff, you can feel free to ask me questions anytime on the mailing list. Thank you.